it's a little bit extra, this section 5.2, adding and subtracting fractions with unlike denominators. It's a little bit extra from what we saw in 5.1. But we've seen, and it seems like we feel pretty comfortable with, once we get the denominators the same or common, that we feel like we can solve these. So I really hope it works the same way on this. It's just we've got to get or force the denominators to be the same. So when it says unlike denominators, we're going to force them to be common or like denominators. So just like what we saw last time, remember, once the denominators are the same, all we're doing is, at least with addition and subtraction, is just adding and subtracting the numerators. Because remember that the denominator is telling us the size of the pieces, right? So when you add the certain number of these size pieces, you're just adding the pieces, which is what the numerators tell us. And then the denominator, that's why it stays the same, is because it's just telling us the size of the piece. But again, the idea with today's lesson here is that we are able to force those denominators to be the same. And one quick note, because in the last unit, right, we did some multiplication and division of fractions. You'll need to remember that you only need common denominators with addition and subtraction. If we were in the previous unit, then there would be no need for any of this, right? Multiplication and division, all you're doing is looking for cross simplification. But with addition and subtraction, we do need these common denominators. All right, so forcing common denominators. Now, it seems like maybe it was last unit, maybe it was 2 units ago, but uh, I know we talked about finding the lowest common denominators, but when operating with fractions, it is not required that you have lowest common denominators. Yeah, it says that right here. Now, it may ask for it just by chance. I don't believe that it will on the assignment, but you may see problems that it will ask for the lowest common denominator. No problem. Remember, you're just looking for, if you want the lowest common denominator, you just find the lowest common multiple, and there are 2 methods for doing that, okay? So you make a list of the multiples. Again, we're just looking at denominators on this. You would look at a list of the multiples, and you'd find the lowest one they have in common. Or, of course, you can use prime factorization, and that would work too. So, 4 steps to forcing denominators to be the same, and that would be for any fractions. So, of course, you look at the denominators and find a common multiple. And like we just talked about down here, there's 2 ways to do that. And then you're going to scale the individual fractions accordingly. So depending on what multiple it is, you scale that fraction. Yeah, multiply each fraction by the multiple that will make the denominators the same. So remember, with fractions, in order to maintain the same value, when we multiply denominators by a value, you must multiply the numerator by the same value. But that's only within this, the one fraction that you're working with. As you look at the second or other fraction, you may be multiplying that by a different value, numerator and denominator, but it's okay to do that because it is a separate fraction, okay? Um, but whatever you do to the denominator, you got to do to the numerator as well. Then you perform the operation, whether it's addition or subtraction. That's what we're mainly looking at here. And then in the end, of course, you're just looking to simplify when necessary. So what we did last time in 5.1, it was just performing the operation, simplifying when necessary, because the denominators were already the same. Now we'll find that common multiple and then force the denominators to be the same, perform the operation, simplify, and then we'll be done. Of course, well, now that may not make a lot of sense right now. However, I hope at least those first 2 steps. I hope the last 2 make a lot of sense because everyone felt pretty comfortable with 5.1. But hopefully we'll see enough examples of this, steps 1 and 2, for you to feel a little bit more comfortable with that stuff. So here's our first example. And yeah, we're going to do some addition right here. Now, do be careful on this because, there is a slight tendency to do this like we would with multiplication or division. And I think we kind of covered this a little bit in the last lesson, but I'm going to cover it again because I do not want you to make this mistake, or that if you have made it, that you'll learn from it right now. So some students right? We get so used to multiplication. It's just, well, 5 plus 2 is 7, and 11 plus 5 is 16, right? Then you say, oh, that can be simplified and it's done. Do not do that, okay? Because with addition and subtraction of fractions, remember that we need the denominators to be the same. So this would be no good, all right? So just like we saw in that last slide, the first thing I want to do is find a common multiple between 11 and 5, my two denominators, 11 and 5. Now, you can use prime factorization. I mean, there's no factorization with 11 and 5 because they're already prime. So perhaps that would be a good method to use on this one, but I'm not going to do that. Um, there's not a lot of students that like that method, although I may show it in a future problem, okay? So what I'm going to do is list multiples of 11 and 5, and then we'll see if we can find a common multiple. Again, I'm not necessarily looking for a lowest common multiple, although we'll find it. But a common multiple, any common multiple will do. So 11, that'd be my first multiple, then 22, and then 33. Now, I'm working with 11 right here, and really what I would like to see is a multiple of 11 that ends in 5, right? Because then I know it is divisible by 5. So I'm going to continue, 33, then 44. There's our fourth multiple, then 55. And I feel like I can stop there, and I hope I can stop there on everyone's behalf, knowing that since we have a 5 in the ones place value here, it's divisible by 5, right? Well, what about 5? Let's go and look at multiples of 5. Is 55 a multiple of 5? It should be because it has a 5 in the ones place value, but let's just make sure. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. I did run out of space there, dang it. Just a little bit of space. 55, there it is. So we see 55 and 55, they're common multiples of 11 and 5, okay? So I'm going to scale both fractions by these multiples in order to change the look of the fraction, but without changing the value of the fraction, okay? So let's look at these two fractions. I'm not gonna simplify anything yet. In fact, we're almost not unsimplifying them. But by doing this, I should end with common denominators, specifically of 55, right? Well, if we look at 11 here, I need to scale that so that it goes up to 55. Well, 55 we can see is the fifth multiple of 11, so I would need to multiply the 11 by 5, which in turn would make that new denominator 11. But remember, if you do it to the denominator, then you must also do it to the numerator, right? So I'm going to have to multiply the 5 by 5. All right, yeah, not 11, but 55. That's better. Okay, yeah, because I was thinking it wasn't improper fraction, so it shouldn't be, but it was going to be. So good, 55 now. And then the numerator is 5 times 5, which is 25, right there. All right, so I got 25 over 55. Maybe I should have written the 55 a little bigger, but it doesn't matter. And then, so that scales that one fraction. So let's go to the 2/5 now, a different fraction, which is okay. But I see that 55 is the 11th multiple of 5. So I can just multiply the 5 by 11, which is going to change that denominator into, well, 55. But remember, if you do it to the denominator, you must do it to the numerator as well. Okay? So I'm going to take 2 times 11 as well, which is 22. All right? Now, we've now made this problem, or forced the denominators to be the same, and it looks particularly like the problems that we did in 5.1. Or hopefully at least you feel that way. Which, in that case, since we've made it this way, forced the denominators to be the same, now we're able to rewrite the problem, but with one fraction, right? So I'm going to keep the denominator the same at 55, but I'm going to take my two numerators and, well, add them together. So I had a numerator of 25 there in green and 22 there in orange. yeah, we just need to add those two together. 25 plus 22. When I add those together, at least in my head, I get 47. It seems right. Well, 47 is prime, and so I mean, you could check and say, well, is 55 only has factors of 11 and 7. 47 is not divisible by either of those, which means that it's actually fully simplified. So on that last slide where we saw the steps on this, sometimes that fourth step of simplifying the fractions, it's not actually necessary, and so you may only go through 3 steps. So just reviewing the 4 steps, right? First is to find a common multiple of the denominators, right? And that's what we did here with these two lists. Then, after we knew what multiple these were, we multiplied or scaled the fractions by these multiples. Okay, so it did change the way they looked, but it did not change the value of the fractions. Now that we did that, it made the denominators the same. So we performed the operation of addition here, and we looked to see if it could be simplified, which would have been the 4th step, but there was no need for that. So 47/55 is our final answer. Now on this one, 1/15 plus 1/10. Of course, we still have the same 4 steps on this, right? I'm going to find a common multiple for 15 and 10 denominators, and then we'll scale the fractions. Then we'll perform the operation, addition in this case. And then we'll look to see if it can be simplified. Now, I said we're looking at 2 methods, and in the last problem, I just kind of made a list, right? So on this one, I'm going to actually look at prime factorization because, and it's again, it's not as commonly used as the list, but it's used from time to time. So for those of you that prefer to have the prime factorization, I'm using this for your sake. Okay, so we look at both numbers, 15 and 10, right? So I'm going to look at prime factorization for both. And this isn't even too bad because we don't have a lot of prime factors for 15 or 10. So I would look at 15, and I see it has factors of 3 and 5. 10, on the other hand, has factors of 2 and 5. Oh, I forgot. I should have done that in that specific order, but it came out pretty nice. Particularly because, remember, we're looking for a greatest common factor here, GCF, which in this case is just this 5 right here, okay? So if my greatest common factor is 5, then if you wanted to find the lowest common multiple, and that's really the idea of prime factorization, you take your greatest common factor, but then you multiply it by the non-common factors, which were 3 and 2. So this will tell us the lowest common multiple for 15 and 10. So 5 times 3 is 15. Times 2, in fact, you could have done 3 times 2 is 6 times 5. In either case, you'll find that the lowest common multiple here is 30. All right, so I need to scale 15 and 10, our denominators, so that they become 30. While on this one, I'm using the lowest common multiple, or at least prime factorization to find the lowest common multiple, which we've seen before. If you prefer the method that we did on that problem previous to this one, by making lists, perfectly fine, right? There's no method where we say you have to use this method or else we're going to mark it wrong. You know what I'm saying? So yeah, this is just another way to come up with the common multiple of, in this case, 30. So and so there may be a question of, well, what do we gotta multiply these by to get 30? And so you could say 30 divided by 15 to get, and that would be 2, by the way. I don't know. Yeah, but again, that's where the list may come in handy, right? You'd say, well, 15, and then 15 plus 15 is 30, and you would have seen that. And I guess multiples of 15 and 10 aren't too bad. Like 10, we know that it has to have its multiples have to end with a 0, which should have made 30 kind of an obvious choice with the list. So if you did that, of course, you would have seen 10, 20, and 30 here. But again, you'll end up with the same answer either way. So 15, yeah, we're going to have to multiply that by 2, which again, that means we're going to have to scale the numerator by 2 as well. And that would then, I'm going to write this out, it's going to change the look of those two fractions without changing their value. So 1 over 15 then becomes 1 times 2 in the numerator is 2, and 15 times 2 in the denominator is 30. And then we'll scale 1/10. Of course, we see that's the third multiple there. So we're going to multiply the 10 by 3 and the 1 by 3 as well, which then will change again. It just changes the look of the fraction, not its value. So then the numerator becomes 3. I might write a decent 3 here. And then in the denominator, 10 times 3, which is 30. So you see how this kind of showed us what the denominator should be with the lowest common multiple, and that, sure enough, we found that it is a common multiple of 15 and 10. Well, now that we've done that, again, that was the first 2 steps in this process. We just need to add those 2 numerators. But again, the denominator stays the same as 30 right there. So we are using addition here. The first numerator 2, and then the second numerator is 3. And what do we get? Well, in the numerator, we got 2 plus 3, which is 5. And yeah, the denominator stays the same. Now, again, we should look and see, well, can 5 over 30 be simplified? Well, yeah, of course, both of these are divisible by 5, so we will simplify that. I guess I'll use orange on this. So let's divide both these by 5. So while we scaled up earlier with multiplication, now we're scaling these down with division. And see if I can get this to work. All right, there we go. So this would equal, as a fraction, 5 divided by 5 in the numerator is 1, and 30 divided by 5 in the denominator is 6. And yes, that's as far as we can simplify that one, so let's box it in. So, in using this method, this third method that I told you about, again, while it may not necessarily be faster, I think you'll find common denominators faster, okay? Of course, there's a fourth method, but you can't use that until 950. So, on this one, with common denominators, when using this method, just keep in mind that you, remember that fourth step to simplify the fractions? You always need to check for that simplification, because when we use this method, it's more than likely that you will be able to simplify in the end. Whereas that first problem that we did in this lesson did not require any simplification at all. Okay, and so when you find lowest common denominators, it is possible you may not have to simplify, but like we saw on that last problem, sometimes it still requires some simplification. So you may say to yourself, well, there's always the possibility of simplification. So if this gets me to have a common denominator sooner, then hopefully it saves time. And I hope that's what happens. And so that's really why I like this method. Okay. So again, the first thing we need to do is find a common multiple. Well, I can force a common multiple to happen. Okay. Now, so what I end up doing in this method is combining the first and second steps. Well, how do I force common multiples? Well, if you remember from that the first problem, I'm gonna use that, right? Where we multiply the one denominator by the other. That's really what this is. And by doing that, you're gonna take out 2 steps in one. Okay. When I finish this, you'll see that we have common denominators, although they might not be in lowest terms, and that's okay. So I would say, look, I got this denominator here 4. Okay. I'm going to multiply or scale the other fraction by that as a multiple. So the 14, then I would multiply by 4, which means I would then multiply the 1 by 4 as well. Right? Well, what does that give us in that fraction? Let's find out. So we're still looking at addition here. In that fraction, I got in the numerator 1 times 4 is 4. In the denominator, I have 14 times 4. Let's go and do that multiplication here. 4 times 4 is 16, carry the 1. 4 times 1 is 4, but plus the 1 in there is 5, 56. So that is my new denominator, 56. Now, if we do this right, it guarantees that this other denominator will be 56. All right? Well, how do we guarantee that? Well, it's because, and it's almost because of the commutative property, but this 14 denominator here, I'm going to multiply it. I'm going to scale that fraction by multiplying it in the numerator and denominator of the other fraction. See that? So it's almost like it's not really an exchange of denominators. It's just multiplying denominators by the other one, right? So what is 14 times 4? Well, yeah, you have that down here. This one right here, right? 14 times 4. We already know it's 56. So that clears the need for finding a common denominator because, well, I just multiplied the denominators by each other. So I get 56 as my denominator. Well, what's the numerator? Let's find that out. 14 times 3. 4 times 3 is 12. Carry the 1. 3 times 1 is 3, but plus the 1 there is 42. So my numerator there is 42. Well, like I said, it gave us 2 steps in one, right? I now have common denominators. I didn't really need to look for a common multiple um, because I just used the denominators that were given. But what did this do? It gave me common denominators. So I don't really need to look for common denominators now, and I can just do the straight operation here. 42 in the numerator plus the other numerator, which is 4. And what does this give us? Well, 42 plus 4, I get 46 on that. And the denominator stays the same at 56. So a little bit more space on this. We should be able to complete it. Well, 46 and 56. Now you could do a little bit more math than I'm going to do, and it may be required, but I see that both of these are divisible by 2. Okay? So I'm going to take them and divide them by 2, like this. Let's go ahead and show that division. So again, there is an exchange of where you're doing your work here. And like I said, generally speaking, when we use this method, there is usually a need for simplification at the end, although it's not guaranteed. So what have we got? 46 divided by 2, that's my numerator. 2 goes into 4 2 times, so 2 times 2 is 4, subtract, I'll zero those out, drop the 6. 2 goes into 6 3 times. So my new fraction, at least simplified this many times, becomes 23, that's my numerator. So next up, I got that 56 divided by 2 as well, right? So let's go ahead and show the long division for that one. 2 goes into 5 2 times. 2 times 2 is 4, subtract. Here's 1, drop the 6, make that 16. 2 goes into 16 8 times. That's 28 right there. And I see that 23 is prime. So that's as far as that one will simplify. 23 28. Now, on the other hand, for this one, 28 is a multiple of 4 and 14. So if you'd used the list, if you had used the prime factorization for this, you probably would have found the 28 lowest common denominator, which we can see here would not have required simplification. But because I use this method, like I said before, it's likely you will need to use simplification in that case. So we're gonna find our common denominators using that last method, which means that all I'm gonna do is I'm gonna take one denominator and multiply it or scale the other fraction by that denominator. Okay. So I would start with well, I guess 9 right here, which is the denominator of the first fraction, and I'm gonna scale the other fraction by a multiple of 9. No problem. Well, that's going to change the value of that fraction. Well, not the value, I apologize. It's going to change the look of the fraction. And yes, we are looking at subtraction here. And so, well, let's go and do that multiplication. In the numerator, 1 times 9 is 9. In the denominator, 18 times 9. Oh, I'll need to do that one. 9 times 8 is 72. Carry the 7. And then 9 times 1 is 9, plus the 7 is 16, 162. 162, there we go. Now in the first fraction, though, I'm going to multiply or scale that fraction by a factor of 18. So that means I need to multiply not only the 9 by 18, but the 15 by 18 as well. All right. Now, one thing I hope you understand from this, just this exercise alone, is that, yeah, you can scale fractions. They may look very different, but you can scale them by pretty much whatever you want, which is why this is tolerable in mathematics, right? It's like, well, could you do that? Well, yeah, because we're not actually changing the value. So what do we get? In the denominator, again, there's no need to do the 18 times 9 because I have it there in green. It's already 162. We know that. However, I do not know what 18 times 15 is, so let's go ahead and do that math. 5 times 8 is 40, carry the 4. 5 times 1 is 5, but plus the 4 is 90, so now we're in the tens place value. 1 times 8 is 8. 1 times 1 is 1, so 180. We need to add those together to find our actual product. 0 plus 0 is 0. 9 plus 8 is 17. Carry the 1. 1 plus 1 is 2. 270. So that 15 over 9 becomes 270 over 162. And by using that method, again, we have forced the denominators to be the same at 162. But I still need to perform the subtraction of that numerator there, numerators, 270 minus 9. So let's go and do that subtraction over here. 270. I know not everyone needs it, but I'm showing it because it's good practice. 270 minus 9, I'll need to borrow from the 7. Make that 10 minus 9 is 1. So I'll drop the 6, drop the 2. 261 is our new numerator. Let's make some space here. We're going to need some. And so in the numerator, I get 261 there from the subtraction, all over 162. And can these be simplified? Yes, they can. How do we know? Because 2 plus 6 is 8, plus 1 is 9, so I know that's divisible by 3. And 1 plus 6 is 7, plus 2 is 9, so that's also divisible by 3. How did I know that from the beginning? Well, I kind of clarified with 2. Again, that's kind of a visual check. I know 162 is divisible by 2, but 261 is not. Neither of these are divisible by 5 or 10, so my next value was 3. So that means that I need to now simplify these, and I will simplify them by dividing them by 3. All right, whatever I get from this, it could be fully simplified. It may not, but we'll find out. Okay, so let's do some long division because we love it so much. So 261 divided by the 3 there. Should make that 3 in blue because it's blue up there. But 3 won't go into 2, but it will go into 26 8 times. 8 times 3 is 24. Drop that, make that 2. Drop the 1. 3 will go into 21 7 times. So that's nothing remaining on that. So I do get 87 there. But also, I need to do 162 divided by 3 also. So 3 won't go to 1, but it will go into 16 5 times. 5 times 3 is 15. Subtract, that makes 1. Drop the 2 to make it 12. 3 goes into 12 4 times. So now I get 54. Well, again, I see that 87 and 54 are both divisible by 3, which means we need even more simplification. And that's okay. It's all right if that happens. Let's fix that a little bit. So let's go ahead and further simplify that. Now, by dividing here by 3, hopefully you remember, that means that I could have just taken these two and divided them by 9. So I kind of purposely did that, divide by 3, because not everyone would notice that. But if you did, you could have done that. And whether you did or not, you should end up with the same answer, one way or the other. Okay, so let's go and do 87 divided by 3 here. 3 goes into 8. 2 times 3 is 6. Subtract. Here's a 2. Drop the 7. 3 goes into 27 9 times. So that new numerator is 29. And the second division there, 54 divided by 3. 3 goes into 5 once. 1 times 3 is 3. Subtract. You get 2. Drop the 4 to make it 24. 3 goes into 24 8 times. So subtract. Oh, that'd be 24. Yep. So 0 remaining, just what we wanted. And that quotient of 18 is our new denominator. And yes, this is it's a improper fraction. It didn't say that it wanted a mixed number here in the beginning. So I'm just going to keep it as 29 over 18. Now, again, you may feel like, well, it's taking a long time there at the end. That's true. And you may think to yourself, well, perhaps it would have been shorter to have just made the list. That's up to you. Okay. Again, there's never a time where we're going to say you have to use a specific method to solve these problems. Some of you, by the way, notice that 18 is a multiple of 9. So you would have just scaled this up so that you had common denominators of 18. If you notice that, that's okay. And so you may think, well, that was a huge waste of time to go through this. I don't think so, because some students may not have seen that right away. Again, that goes back to our schema conversation that we had at the beginning of this class, where, if you have enough experience to notice that, yes, that's true, and you would have gotten the same answer fairly quickly, by the way, but not everyone will notice that. So prime factorization on this one, 5/6 minus 5/14. And yes, we will need to simplify if it's necessary, but we'll find out if it is or not, okay? So we look at the two denominators. Let's start with 6, and I want its prime factors, which would just be 2 and 3 right here, right? So I'll show it over here. 6 is the same as 2 times 3. 14, though, two prime factors for that as well, 2 and 7, okay? And again, if we list these straight up and down like this, then it just comes out very convenient. And so my greatest common factor here is, well, just 2 is the only common factor we have. But what we would like is the lowest common multiple, which requires the greatest common factor, but also multiplication of the other non-common factors, which was 3 and 7. So multiplying this out, 2 times 3 is 6, 6 times 7 is 42. So that means I need to scale 6 and 14 up to 42. All right? Well, I know that 6 times 7 is 42, and we kind of expect you to know that at this point as well. So I'm just going to show that part. Okay, 6 times 7. Now again, you're going to scale the numerator by the same factor, and this will create a new fraction for us, the first fraction, where the denominator is, yep, that's the lowest common multiple of 42. The numerator, though, 5 times 7 is 35. Right? So that's that one fraction there. So 14, what do I got to scale 14 by to make it 42? Now, you could make a list here. You could do 42 divided by 14 as well, which if you did that, since we're not familiar with our multiplication tables of 14, you may have to make a list of multiples of 14 anyways, but you'll find that it's the third multiple. So when you subtract that, you get a remainder of 0, just what we want. So this means that for 14, 5/14, I would need to multiply the numerator and the denominator by 3. All right? And yes, now we see that. We know that 14 times 3 is 42. And that's again, that's kind of the main objective we're going for in these first two steps, in finding the common multiple, and then denominators that are the same. We force the denominators to be the same right there. But the numerator there, 5 times 3 is 15. Well, let's go ahead and subtract this and see what we get. Okay, so the denominator stays the same at 42, but we need to do some subtraction in the numerator. So that's 35 minus 15. And again, I'm showing this step right here. If you're showing this step right now, you may get to the point where you've done enough of this where you're like, I don't really need to show this step. I know I can do this part right here, and then you'll end up with that in other fraction. I'm showing this work because right now you may not be as familiar with that, and I hope that's okay. So in the numerator, I have 35 minus 15. Let's go and stack this and subtract. I'll use a different color, I guess. Green. 5 minus 5 is 0. 3 minus 1 is 2. So 35 minus 15 is 20. And that would be my new numerator. All over 42, by the way. And yeah, now again, see, even though we used common denominators, or the lowest common denominator, there still is a need for simplification on this, okay? Because I got 20 and I got 42, both of those have well, there's a 0 and a 2 in the ones place value, which means they're both divisible by 2. So I need to divide these both by 2, right? Now we should know 20 divided by 2 is 10. But 42 divided by 2, that may be a little different. So let's go and do that division right here. 2 goes into 4 2 times. 2 times 2 is 4. So that zeroes that out. So how many times does 2 go into 2? Once. So I get 10 over 21. That can't be simplified any further. So that's about as far as we can take that. Now again, was that faster? Perhaps. Like if you did 6 times 14, use that method, you could have. If you made lists of these two in multiples, then you would have found the 42 anyways. So again, even whether you prefer one or not, preference is good, but does it mean it's going to be faster or not? It depends. It just depends. All right, 6/11 minus 1/2, and of course we'll simplify this if it's necessary. Now we use those. We used methods 3 and 2 twice. So we did the denominator thing twice, and then we did the prime factorization twice. So on this one, I'm going to use lists. All right, and again, I hope that doesn't cause too much confusion. But again, if you don't like the list, then use your method. You should end up with the same answer no matter which method you use. Okay, so I'm going to use lists on this one. So let's go ahead and find lists of multiples of 11. So I got 11. 11 plus 11 is 22. I'll show more multiples than we need on this one just to show that it doesn't matter, but it's really depending on if you realize that it is or not, right? Some of you'd say, well, you could stop at 22 because of the 2 and the 1's place value, and that'd be fine if you did. So I'll stop there, and then 2, right? And if you knew that 22 would be the lowest common multiple, you could just start seeing, well, what would I multiply 2 by to get there? Who knows? It doesn't really matter because I'm going to show the list. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, whoops, 20, and then 22. I kind of added a space there. But that is the 11th multiple of 2, right? So I go to these two values. We got 11 and 2. And I see that 22 is kind of our target value for our denominators. Now, if by chance you didn't see the 22 and went all the way up to 44, you would still be fine, right? Because it doesn't matter if they're the lowest common denominator. All that matters is that they are common denominators, okay? So let's see. We're going to scale these two fractions, and we are still working with subtraction. Let's start with the 6/11, right? So I see 22. That is the second multiple of 11 right there. So 11 times 2 is 22. In the numerator, I have 6 times 2, which is 12. Now, at this point, I'm going to put right now the denominator for 1 over 2 that we're changing it to, right? It needs to be 22. So I can pretty much write that in right now. It's just a matter of, well, what would I multiply the 2 by to get 22? Well, 22 is the 11th multiple of 2. So yeah, that means I would need to then have multiplied it by 11. Which means I also need to multiply the 1 by 11 as well in the numerator. So what do I get from that numerator? 1 times 11 is, well, 11 right there, okay? So again, whether you're doing this math here right, 2 times 11 and you get the 22 doesn't really matter because you should know once you see this 22 that this one is going to end up being 22 as well, as long as you've figured out the correct common multiple. Now notice, by using this list, we actually used the third method as well, right? Where we just said, look, take the 2 and multiply it by this fraction. Scale this fraction by 2. Or this fraction, we scaled it by the other denominator. So sometimes it just happens that way where the two methods end up becoming the same method, okay? Now, whether you did or not, again, doesn't matter because we're going to come up with the same answer. So, denominator of 22 here, no problem. We are using subtraction. Well, what are we subtracting? 12 and 11. And yes, this is subtraction, so order does matter. You would not want to do 11 minus 12. It's always the first numerator subtracting the second numerator. So that didn't touch the denominator. It's still 22, but I can do 12 minus 11 to get 1. And sure enough, that is non-simplifiable. So that completes that problem. Fractions with whole numbers. Remember, and we've seen this slide before, it's true, that if you ever see a number by itself, at least when we're operating with fractions, you just may want to show it over 1, okay? And now when you do this, by the way, especially when we need common denominators with addition and subtraction of fractions, I prefer the third method where it's like, hey, just multiply the other fraction by the other denominator, okay? Scale the fraction by the other denominator. So, but again, we'll show it as over 1 if we ever see a whole number by itself. Like this one, okay? So we got that 15 over 8 plus 7, but I'm going to show that as 7 over 1. Why? Because I can. And we are operating with fractions here, so I think it'd be good to see that as a fraction, 7 over 1. So now, actually, although I'm using the third method on this one, it really is not going to matter on this which method you use. I mean, 1 doesn't even have prime factors because it by itself is not, it's not prime or composite, right? Because 1 is a unique value. So you could split up the 8 and you'd find all its prime factors. Just you're going to end up multiplying. You'd end up multiplying 8 by 1 and 1 by 8. Okay, so that's why I say whenever I see whole numbers, particularly that third method comes in pretty handy. And so I can just say, well, look, I'm going to multiply the 8. I'm going to scale the 7 over 1 by factor of 8, the other denominator. So I'll take 1 times 8 and 7 times 8 right there, right? So in my two fractions, that's the second fraction. And so I got 7 times 8, which we know is 56. 1 times 8 in the denominator is 8. And then, yeah, seeing that that first fraction, I mean, scaling it by 1, it's not going to change either of those values. It will still be 15 over 8. Okay, so I actually, well, say I like operating with whole numbers isn't necessarily true, but I'm nerdy that way, so I kind of do. Maybe I'm just ashamed to admit it. But in any case, you can see that once you see that it's over 1, it becomes a very easy calculation once you start just multiplying with the denominators like that. Again, that's the third method. So let's go ahead and perform our operation here now that we have common denominators. We're going to keep the denominator at 8. We are performing addition here, but I got my first numerator at 15 and the second one at 56. We'll stack these just to show the addition right here because while some of you may be able to do that in your head, not everyone can. So let's go ahead and add these together. 5 plus 6 is 11, carry the 1. 1 plus 1 plus 5 is 7, 71. So my new fraction with a denominator of 8 still becomes 71 over 8. And that cannot be simplified any further. So that's my final answer. 7 minus 15/8. Yeah, I understand some of you feeling probably like, well, you're using the same numbers. It's true. I mean, it's not going to matter if we did change these numbers. So it's just reversing, by the way, right? Now the 7's in the front, 15 over 8 is in the back part of this. And we did change the operation as well. So even though you may think, well, it's pretty much the same problem, it's not. Now, if it was addition, it would be the same problem. We just moved where the numbers were, but we also changed the operation, which is significant. So I'm going to show that as 7 over 1, right? And whether you make a list or you just multiply by the denominators or scale them by the denominators or use prime factorization, it's going to be the same method either way. So I'd be looking at this 1 right here, and I would scale the other fraction by that factor. Now, of course, the nice thing about that is that it does not change the values of 15 in the numerator or 8 in the denominator. Okay, so we didn't need to scale that fraction because it's 7 over 1. But I do need to scale that first fraction of 7 over 1 by a factor of 8. So we'll do 7 times 8, which we know is 56. And we should also know that 1 times 8 is 8. And yet we should be able to do that without relying on the previous problem. So we have a new common denominator. But we are subtracting. What are we subtracting? Specifically 56 minus 15. And yes, it does need to be in this order. So we're going to subtract those. Again, we're keeping our denominator the same. Let's go ahead and see, stack this up and see what we get from the subtraction. So let's go ahead and subtract that out. 6 minus 5 is 1. 5 minus 1 is 4. So I get 41 over 8. And yeah, I do not see that that can be simplified. So we'll keep it as an improper fraction. Although, yes, we should have the skill set right now to be able to change that into a mixed number if by chance it wanted us to. But I don't believe that it will on the assignment. And another thing you should notice about these last two problems is they were much faster, not only because we've covered this already, but particularly because once you see a denominator of 1, operating with 1 it should be fairly easy, which is why math people love 1 so much. I mean, other than its other inherent properties, but operating with 1 makes things very, very, very convenient.